I was watching a colleague recently. Let's call him Mark. He's the definition of high functioning. Inbox always at zero, juggling 3 urgent projects, maintaining that perfect polished corporate smile. He actually bragged during lunch about how he hadn't taken a real weekend in months, laughing off his insomnia as if it were a superpower. To him, the fact that he was constantly overriding his body's limits was proof of his strength. But then, something incredibly minor happened. The office printer jammed. It wasn't a crisis, just a piece of stuck paper. Yet Mark didn't just get annoyed, he completely unraveled. He stood there staring at the flashing red light. His hands started shaking uncontrollably, and he just slid down to the floor right there in the hallway, unable to speak or move. It was terrifying because it was so sudden. One minute he was the master of his universe, and the next he was a statue. That moment wasn't about the printer. It was the exact second his brain decided to slam the door. We like to think of burnout as a slow, foggy exhaustion. But looking at him, I realized the truth is much more brutal. It's a biological mutiny where your nervous system stops negotiating, pulls the emergency brake, and simply tells you, sorry, to end the boss. That image, that instant collapse, it's just so powerful because it forces you to throw out all the usual talk about, work-life balance.
It does.
And see burnout for what it actually is, a system breakdown. And Mark's story, as scary as it was, it's the perfect way into our deep dive today. We're going to be looking at modern corporate burnout, but through this really fascinating lens of our own evolution.
Right, because Mark's story is, it's a perfect example of this central conflict of modern life. Our bodies they're these incredible machines of adaptation.
Sure.
But the world they adapted for was the Pleistocene era. We're talking about a hunter-gatherer world that's over 95% of human history?
So our hardware is ancient.
Ancient, and that fundamental problem is what we call the evolutionary mismatch.
Okay, so let's unpack that. That feels like the absolute foundation of this whole thing. What's the real difference between modern stress, like in an office, and the kind of threats our ancestors faced? Why can't our bodies tell them apart?
Well, the mismatch happens because the world changed so fast. Think about the Industrial Revolution, and then the speed of change just exploded after the mid-20th century.
The Great Acceleration.
Exactly. And our genes, they evolve at this glacial pace. They can't keep up.
Yeah.
So our stress response system, our hardware, it's ancient. It's perfectly tuned to handle immediate physical life or death threats. But we're trying to run this modern 24/7 high-demand software on it.
When you think about an ancestral threat, it was simple. It was, say, a lion.
The lion, right.
And that lion had 3 key features. 1, it was acute. It just appeared suddenly. 2, it was lethal. You mess up, you're dead.
Yeah.
But the third point is the most important one, I think.
Yeah.
It was always followed by resolution. You either got away or you didn't, but afterwards, you rested. The system got to turn off.
That's the key. That off time, the whole system is built for these short, intense, explosive bursts of energy, and then, crucially, a period of recovery and repair. But the modern stressor, like a deadline or a horrible email thread.
Or a jammed printer.
It's almost never lethal, but it triggers the exact same fight-or-flight cascade that was designed for the lion.
And unlike the lion, it just never, ever goes away.
It's relentless. It is chronic, and it is pervasive. And that's what we call the relentless activation cycle. That digital connectivity you mentioned, the constant flow of information, the pressure to always be available, that has completely erased psychological off time.
We're basically taking a system that was designed for a 100-meter dash and forcing it to run a marathon forever.
Without water breaks. And the consequences of that they're profound. This isn't just a feeling of being stressed. This chronic activation causes real systemic damage. It messes with your immune function. It throws your hormones completely out of whack. It degrades memory.
And inflammation, right? I always hear about stress and inflammation.
It massively increases inflammation, which we now know is at the root of so many chronic diseases.
When you scale this up to the whole population, you can actually see the toll this mismatch is taking on what you call our evolutionary fitness. That sounds incredibly dramatic.
It sounds dramatic, but the data is pretty compelling. If you look at global trends since that great acceleration in the 50s, you see chronic inflammation basically becoming the norm. And you see really clear evidence of reproductive decline.
How does my overflowing inbox connect to, reproductive fitness?
It's all about resource allocation. The stress response system, which we're going to get into, its only job is immediate survival.
Right now.
Right now. And when your body thinks it's constantly in danger, it diverts energy away from any long-term projects. And reproduction is the ultimate long-term project.
I see. So if your brain thinks there's a lion around the corner, It's not going to prioritize making a baby.
Logically, no, and the data shows it. Since the 50s, there's been a really significant and frankly concerning drop in global fertility rates, lower sperm counts, decreased motility. The main stress hormone, cortisol, can directly interfere with the hormones that kick off the whole reproductive process. It's a direct biological consequence of this mismatch.
Okay, so that's the why. That's the mismatch. Now to get into the how. How did Mark's system go from being this high-functioning machine to just desktop off in a split second?
Right. And that brings us to the actual physiological machinery that gets hijacked. The hypothalamic pituitary adrenal axis, or, the HPA axis.
The HPA axis, okay.
It's this beautiful three-part communication system in our body, and it's built for one thing: acute survival. It's the engine of fight or flight.
So walk me through it. An email with a scary subject line comes in. Where does the cascade start?
It starts in your brain, in the hypothalamus. It senses that threat, and it releases a hormone, CRH. That's signal number one.
Okay.
CRH travels a tiny distance to the pituitary gland, which then shoots out hormone number 2, ACTH, into your bloodstream.
And that's the signal that goes out to the rest of the body?
Well, specifically to the adrenal glands, which sit right on top of your kidneys. ACTH hits them, and that's the trigger for the main event, the release of corticosteroids. In humans, that's mostly cortisol.
Cortisol, the famous stress hormone. And when it's working properly for that lion, what is it actually doing?
Oh, it's brilliant. It's all about preparing you for intense physical action. It floods your bloodstream with glucose for instant energy. It shuts down everything non-essential.
Like what?
Digestion, growth, and very importantly, your immune system. You don't need to fight off a cold when you're fighting off a predator. It also jacks up your heart rate, your breathing. It's an amazing emergency system.
But the emergency is now happening every hour. Every time a notification pops up.
Yeah.
What does that do to us long term?
The adaptive response becomes incredibly damaging. This chronic pressure from modern life just causes this aberrant release of cortisol. The system is either stuck on high or it just loses the ability to regulate itself properly. It becomes dysregulated.
And what does that constant flood of cortisol do to the brain itself, to the physical structures?
This is where it gets really unsettling. Over time, high levels of cortisol are literally toxic to brain tissue. The two parts of the brain that are supposed to manage this whole system are the hippocampus and the amygdala.
Hippocampus for memory, amygdala for fear, right?
Basically, yeah. The hippocampus is also crucial for hitting the brakes, providing the negative feedback to shut the whole stress response down. Chronic stress makes the connections in the hippocampus wither. It can even stop the growth of new neurons. The structure literally shrinks.
Wow.
At the same time, the amygdala, the threat detector, does the opposite. It becomes hyper-responsive, it physically grows larger and more active.
So you're creating a vicious cycle.
A perfect vicious cycle. The part of your brain that calms you down gets weaker, and the part that sounds the alarm gets louder. This is why we see such a strong link between chronic stress and things like depression and PTSD. The brain's regulatory architecture is being physically damaged.
That is terrifying. It's not a feeling, it's brain damage.
Yeah.
And it's not just psychological, right? The modern office hits us with other mismatches that keep that HPA axis fired up.
Oh, absolutely. Think about compulsory sedentary work. That's a huge physical mismatch. Our bodies evolved to move, to do hard physical labor every day. Sitting in a chair for 8 hours is itself a low-grade stressor. And then there are the temporal mismatches.
Like night shifts.
Night shifts, or just working across different time zones constantly. It throws your circadian rhythm into chaos. And since that rhythm helps control the natural daily cycle of cortisol, messing with it just adds another layer of dysregulation to the HPA axis.
And then you add the digital layer on top of all that. The things designed to make us more productive are actually just keeping us in a state of constant low-level threat.
Insidiously so. It's not just the sheer volume of communication, it's the lack of social context in digital work. But the most direct threat comes from things like electronic performance monitoring, EPM.
So software that tracks every click, every minute you're active.
Exactly. Knowing you're being constantly watched and evaluated creates this perpetual low-grade threat signal. It's the digital version of feeling like there's a predator always watching from the bushes. You can never, ever feel safe and let your guard down, which is what the HPA axis needs to recover.
So when Mark slid down that wall,
Yeah.
that wasn't just frustration.
That was the mutiny. That was his system hitting its limit. We call that limit allostatic load.
Okay, what's that?
Think of your HPA axis like a credit card for emergencies. Allostasis is the process of making the minimum payment each month, all the little adjustments your body makes to stay stable. Allostatic load is the debt you accumulate from making those adjustments over and over and over without a break. It's the wear and tear.
So Mark's credit card was maxed out.
Completely. The system ran out of credit, it couldn't adapt anymore, so it stopped negotiating and just pulled the emergency brake. That total shutdown of his body was the nervous system's last-ditch effort to protect him from complete self-destruction.
Stumbling.
Yeah.
But it also raises the big question, why him? Why did he collapse and not the person in the cubicle next to him facing the same pressures?
And that takes us to the next crucial part of this, the idea of individual variation. How our stress response is programmed, often decades before we ever set foot in an office.
This is where we get into life history theory.
Exactly. And the Adaptive Calibration Model, or ACM. The traditional view, what we call the toxic stress model, is pretty simple. It says that early life stress is always bad. It leads to dysregulation and damage. You were stressed as a kid, so now you're impaired.
It's a deficit model. You're broken.
Right. But the ACM, the evolutionary model, it flips that on its head. It suggests that early stress isn't just damage. It's information. It's a cue from the environment that helps calibrate the developing stress system for the world it's likely to face as an adult.
So it's not broken, it's just calibrated for a different, harsher world.
Precisely. It's a conditional adaptation. Life history theory says all living things develop along a continuum, making trade-offs based on the environment they're in. We usually talk about this as a slow versus fast strategy.
Okay, let's break that down. A stable, safe environment leads to what?
That leads to a slow strategy. If you grow up in a supportive, predictable world where resources are reliable, it makes evolutionary sense to invest in the long term.
So you take your time.
You take your time, you delay puberty, you invest in stable relationships, you have fewer offspring but invest heavily in them, you plan for a future, you expect to be there.
And if the environment is dangerous and unpredictable?
That pushes you toward a fast strategy. If there's violence, instability, if you might not live to see next year, it makes no sense to save for the future.
You focus on the here and now.
Right. The strategy shifts to immediate gains. Earlier puberty, more risk-taking, more impulsivity. You focus on survival and mating right now because tomorrow isn't guaranteed.
And this adaptive calibration model says that this fast strategy can actually show up as two very different kinds of stress responses.
Yes. This is where it gets really interesting. It's not just one broken response. It's two distinct adaptive profiles that can emerge from high childhood adversity.
What's the first one?
The first is the vigilant profile. This is probably what most people think of. It's characterized by heightened physiological reactivity, a hair trigger HPA axis.
Always on edge.
Always on edge. And that's adaptive in a dangerous world because you can react instantly to threats. But it comes with costs. High anxiety, being hyperreactive, maybe prone to reactive aggression, lashing out when you feel threatened.
So someone like Mark, who is always pushing, always performing, always on, he might fit that vigilant profile. He was calibrated for danger, which made him a star performer until he wasn't.
It's very possible. He had the pedal to the metal constantly. Now, the second profile is almost the opposite, and it tends to come from even more severe stress. It's the unemotional profile.
And that's a low or blunted stress response. How does that make sense? Why would more trauma lead to less of a reaction?
It's predicted to develop under severe chronic neglect or deprivation. Think about it. If the world is so overwhelmingly dangerous that being constantly vigilant is pointless and exhausting, the most adaptive strategy might be to just tune it out.
To shut down your own sensitivity.
To shut it down. Generalized unresponsiveness becomes a survival mechanism. It's associated with low empathy, high impulsivity, and often a more calculated, proactive kind of aggression. It's just another tool for survival in a brutal world. Both profiles are adaptations, even if they look like pathologies in a safe, modern office.
That is such a powerful way to reframe this. It's not dysfunction, it's a survival strategy that's now mismatched with the environment.
Exactly. And it's why telling someone with a vigilant, fast strategy calibration to just do yoga or relax is so ineffective. You're asking them to fight their deepest evolutionarily programmed blueprint for survival.
So if this programming is so deep, we have to ask when it's happening. When is the HPA axis actually being calibrated?
The wiring happens incredibly early. The first and most critical window is the perinatal period before and just after birth. The brain is undergoing explosive growth, it has incredible plasticity, and the circuits for the stress response are being built.
So how does a mother's stress get to the fetus? I thought there was a barrier?
There is. Nature is smart.
Mm.
The placenta has an enzyme. It's called 11-dollar beta HSD2. You can just think of it as the placental shield. Its job is to find and deactivate the mother's stress hormones, like cortisol, before they reach the fetus.
But it's not a perfect shield.
No. If the mother is under chronic severe stress, that shield can get overwhelmed, its activity can be reduced, and more cortisol gets through to the developing fetal brain, where it starts to program the sensitivity of that baby's future stress response.
So the calibration can literally start in the womb. What about right after birth?
After birth, there's another protected phase. It's called the stress hyporesponsive period, or SHRP. In humans, it's roughly the first 6 to 12 months. During this time, the HKA axis is naturally turned way down. The baby is relatively unresponsive to stress. It's a protected time for development.
But what if the care during that time is poor?
That's the key modulator. If the quality of care is poor, say, there's prolonged separation from the caregiver animal models show that the baby is forced out of that protected SHRP phase too early. It essentially turns the HPA axis on ahead of schedule and sensitizes it, making the individual hyper-responsive to stress for the rest of their life.
Wow. So the severity of that early stress really determines the outcome.
Yes, human research really backs this up. There's a clear split. On one side, you have that hyper-responsive HPA function. This is linked to mild or moderate stress, like prenatal anxiety or high conflict in the home. It results in kids with higher baseline cortisol and bigger cortisol spikes when they're stressed. They're primed for threat.
And on the other extreme?
The other extreme is hypocortisolism. Lower baseline levels of stress hormones and a blunted, dampened response. This is what you often see after severe chronic neglect, institutionalization, or extreme abuse.
Why blunted? Did the system just burned out already?
It's more like a deep recalibration. It might be the body's ultimate defense against a threat that is so overwhelming and inescapable that reacting is pointless. It's a protective shutdown. Interestingly, you also see this profile in some veterans with PTSD.
So this all ties into the developmental match-mismatch theory, the idea that these adaptations are designed to match the world the baby expects to live in.
Precisely. The match scenario is when early stress correctly prepares you for a stressful adult life. That vigilance might actually make you better at navigating a dangerous environment. You might be a better soldier in a war zone, real or metaphorical.
And the mismatch is when you're programmed for war, but you find yourself in peacetime.
Exactly. Then all those costly adaptations become liabilities. You have high anxiety for no reason. You take risks that aren't necessary. Your programming is a drag on your fitness because it doesn't match your safe, predictable world.
Which brings us to that great metaphor. Orchids versus dandelions. Not everyone is programmed with the same sensitivity.
Right, that's the final layer here. Dandelions are the generalists. They're resilient. They aren't much affected by their early environment, good or bad. They do pretty well everywhere.
Sturdy.
Very sturdy. But orchids are the specialists. They're incredibly sensitive to their environment. In a harsh, stressful environment, they wither. They develop these high-cost adaptations like severe HPA dysregulation.
Well, what if they're in a great environment?
Then they thrive. In a really supportive, enriched environment, they can actually outperform the dandelions. Their sensitivity becomes their superpower.
So orchids are the ones whose stress systems are most open to being programmed.
That's it. And fascinatingly, research suggests that this sensitivity, this orchidness, follows a U-shaped curve. The kids who grow up in either very safe or very stressful environments tend to become the most sensitive, the most plastic. The orchids.
Okay, so putting this all together, burnout is this biological mutiny caused by an evolutionary mismatch. We can't wait for our genes to change. So the only real solution is to change the environment.
We have to. And that means rapid cultural evolution within our organizations. We have to intentionally design workplaces that mitigate these mismatches. The company has to adapt to the human, not the other way around.
So how do we do that? How do we start reintroducing the things our bodies need back into the concrete box of the office?
There are 5 major areas we can tackle right away. Let's start with the most obvious one, our complete separation from nature.
Right. Biophilia and greenery. We live and work in these sterile boxes, and studies show that just living in a city raises activity in the amygdala, the brain's fear center.
It literally puts us on edge. And the fix is so simple. Integrating natural elements, plants, views of nature, even high-quality pictures of nature, has measurable physiological effects. It lowers blood pressure, reduces stress, and improves concentration.
And it's not just psychological. It cleans the air.
Yes, it directly fights sick building syndrome. Plants are amazing filters for indoor air contaminants that cause headaches, exhaustion, and dizziness. Putting plants in an office is a health intervention, not a decoration.
Okay, number 2, sunlight. Another fundamental biological need that so many offices are designed to ignore.
It's non-negotiable. We need natural light to produce vitamin D. And vitamin D isn't just for bones, it's critical for regulating mood. Low levels are linked to depression. It's also protective against a whole host of diseases.
Like what?
Cancers, heart disease, diabetes. Relying on fluorescent lights all day is starving our bodies of an essential nutrient.
All right, number 3 is about tackling that sedentary mismatch, getting us out of our chairs.
Right. And the goal isn't to make everyone run a 5K at lunch. It's about increasing what's called non-exercise activity thermogenesis, NEAT. It's all the energy you burn from small, everyday movements. Fidgeting, walking to the copier, standing up. It's the movement our ancestors did all day.
And that adds up, doesn't it?
It's huge. Studies show obese individuals sit for about 2 hours more per day than lean individuals. That difference alone is about 350 calories.
So what are the cultural fixes for that?
They're simple. High-top standing desks, moving the coffee machine farther away so people have to walk to it, and just normalizing movement, making it okay to take a 10-minute walk-and-talk meeting instead of sitting in a conference room.
Number 4 has to be about rest. Fighting that always-on culture and respecting our body's natural rhythms.
Yes, that afternoon slump everyone feels, that's not a sign of weakness. It's a programmed dip in our circadian rhythm. It's universal.
And we fight it with coffee and sugar.
When the science is clear that a short nap is a far superior tool, a 20-minute nap improves alertness, logical reasoning, and memory consolidation way more effectively than caffeine.
But the stigma around napping at work is huge.
It's a massive cultural hurdle. Companies that are serious about this need to not just permit napping, but provide a quiet, dedicated space for it. It's not about being lazy. It's about optimizing cognitive function and reducing costly errors.
Okay, and finally, number 5, harnessing our need for connection, social and even animal connection.
We are a deeply social species. We evolved to cooperate in groups. Isolation is a major stressor, and social support is one of the most powerful buffers against burnout.
How does that work physiologically?
Positive social interaction releases oxytocin, the bonding hormone. And oxytocin is a natural brake on the HPA axis. It calms the stress response and makes us feel safe.
Which is where, surprisingly, dogs come into the workplace.
It's not surprising when you think about it. We've co-evolved with dogs for 15,000 years. Their presence literally taps into our ancient social circuitry. Absolutely. Studies show having dogs around increases group trust, cooperation, and cohesion. And just petting a dog for a few minutes measurably increases oxytocin levels in humans, directly lowering stress. It's a 15,000-year-old solution to a 70-year-old problem.
This has been an incredible deep dive. We started with Mark on the floor, and we end here understanding that burnout it's so much more than a buzzword.
It's the logical, biological consequence of an evolutionary mismatch. It's the HPA axis being pushed past its limits by chronic, non-lethal stress until the allostatic load becomes too much to bear.
And we know that an individual's vulnerability to that load, whether they're vigilant or unemotional, is often programmed deep in their past by their early environment, just as life history theory would predict.
That final collapse, that biological mutiny, isn't a failure. It's a necessary emergency brake, the nervous system protecting the organism from destroying itself. And since we can't change our biology, the only path forward is through deliberate, intentional cultural evolution. We have to redesign our world to honor the ancient bodies we inhabit.